Hello, ladies and gentlemen. I have a pleasure to open, in fact, this stage because my presentation, my keynote is the first one. That's why this is as well pleasure for me. Sebastian Grabowski, in fact, architect's lead or lead of architecture around Industry 4.0, Internet of Things, Industrial IoT. I'm working in European zone. Because I got many questions, I'm not connected with Orange Poland. It's very important. Orange Business, there is the part of Orange Europe organization. I'm in the team of Smart Industry Consulting Europe. It means that from time to time I'm advising. On the other hand, I'm creating the architecture. And as well, the main role is just connect some dots around this quite sophisticated domain. What is as well important, there is as well for me way to give you the message that if you are interesting around some technologies around smart city, feel be welcome on my YouTube channel, which is called Miasto Miasto. I'm still looking for some fans, where I'm just showing some smart ideas, smart technologies, which are implemented in Polish cities. Okay, here we go. My mail, if you have any additional question, because I will not explore a lot this domain because it's quite deep. However, I will just give you some remarks that you can follow it afterwards. About devices, as you know, there are billions. The last report I got from internet showed that currently, I don't know that is right or not. However, they are showing that we have more than 22 billions of devices. I think it's much more. It's really hard to even collect or even count how many devices are on the market worldwide. Why? Because what we can count, for instance, washing machine. We can count some intelligent cars with some intelligent modules inside. We can count as well some modules or devices we can touch. However, there are much more that are invisible for us. That in my private analysis, I think that currently there are much more devices than only 22 billions. What is important as well, that area of smart cities, Industry 4.0, Industrial IoT, those domains don't exist without smart devices. Because if you would like to improve the process, if you would like to create some additional value for some intelligent procedures, intelligent solutions, services, platforms, systems, we need smart devices, because without that, we will not know how to measure some interaction between machine, person, human, etc. That for sure, guys, there are much more on the market. There are everything, and when we are this domain is fabulous. However, as well, this domain has a lot of problems to understand in or where or how we are defining this domain. Because currently, you can find something in your garden at your home, air conditioning, this kind of stuff in your garden, intelligent cars, autonomous cars. On the other hand, in car, as you know, because you are experiencing it, you have the bus scan that you can get all of information which are happening online on your cars, speed limit, problem with your tire, pressure in tire, etc. Those are measured online and just exposed on the panel for the driver. Shoes. I didn't put here, unfortunately, the one big domain, which is quite big, porno business, as well currently using a lot of intelligent sensor just to increase attention of end users. Industry, Kron, etc. This business really needs smart devices. And there are as well some reports which is showing that for sure IoT connections to reach billions by 2024. ABA envisioned that in fact last year about 2.7 billion active AI-enabled devices. Edge AI. Edge as well is becoming so popular now because we know that we have a problem with compute power. But about that will be in the moment. Over here, I allowed myself just to create some very simple template just to show what we are speaking about, which domain in fact, it's important for creating of IoT or industrial IoT service. Whatever service or whatever we will imagine about intelligent services, they are always look the same. They always have the same combination of different blocks. They could be much more sexy. They could be much more interesting. However, blocks are still the same. We are starting from the device. After that, it depends how powerful should be this device. What we're going to send to the cloud. It could be edge, already embedded, and in a moment I will speak about it. There is as well big area which unfortunately underestimated, connectivity. Majority of the problems which are happening around IoT, industrial IoT, are connected with connectivity. We have so many different protocols, and fortunately there is my specialization. They are starting from the connectivity. Currently we can get information, we can capture the information directly from the field, shopping floor, in the factory, etc., or in the city. However, we need connectivity. We could use different narrowband protocols, CAT-M, NB-IoT, LoRaWAN, Sigfox, and many more, just to capture, get information from the field. And my experience says that probably 80% starting from the connectivity, that we underestimating this domain, that we treat the simple SIM card as a SIM card as a connectivity. It's not like that. We should know much more about it. We should know the protocols like MQTT, LV, LW in English, or LV, M2M protocol, light protocol, which really helps us to manage efficiently the device in the field. As well, we have a cloud. There is a big golden cow, let's call it like that, for hyperscalers, because we need the cloud. If you are working in a big area of big domain, we need the cloud just to store data. It is required. Among the cloud, we have probably three main blocks. IoT platform, I call it device management, because if you would like to manage something in the field, we need something to manage in the one coherent way. We cannot have 2 or 3 or 5, 6 different device management to handle different protocols. We should have one. That's why all of hyperscalers, they have their own IoT hub, IoT part, IoT, I don't know, whatever they're gonna name it. After that, if we capture some data, we need some tools, some frameworks, just to understand what those data give us. Because if we don't have intelligent frameworks, if we don't know how to handle data, how to take information from the data, certain information, we will never succeed. And finally, the easiest way, if those are more or less standardized, there is the visualization, because finally, our end user and customer, or even for me, I would like to know what is happening, what happened, for instance, in the smart city where the air is very bad. And we have some sensors in the city, I don't know, 1,000 of sensors, and we have to as well understand that air is bad or is good. That's why we need as well, we need some very simple visualization. It could be both application, dashboard, or whatever we're gonna imagine. Now I will focus a little bit on this domain, because I mentioned as well that the problem, in many cases, started here. However, the case of cameras, intelligent cameras, and some algorithms that we can onboard to the camera. We are sending streaming. Streaming, in general, needs a lot of bandwidth and as well storage. That's why if you're gonna send it, we should be prepared just to create over here quiet big pipe. That's why operators, big telecoms, some years ago and even now, I think that all of telecoms are currently under the development 5G network, which really allows to provide big bandwidth and very small latency. However, if this we almost could cover, we for sure need to add just for effectiveness, just to, I even call it just to be smart. We need to put some computer power, some intelligent algorithm over here, which is going to be connected with this device, because we can, in fact, handle a lot of different scenarios over here. That's why this pipe cannot be so huge, because we're going to send to cloud only certain information that we really take care. And how we are working in Orange Business Services in Europe. What is important? We are started to speak some years ago about edge machine learning. In fact, it's embedded machine learning. Together with our partner, Icono, it is the Swedish company, about 25, 30 data scientists. They figured out, created, invented the model, very smart model, libraries. They did it in C++. They are very efficient, they patented it. How to create some very intelligent algorithm, we call it machine learning algorithm, that are ready to put on the device, on the chipset. That's why, using the same thin pipe, we can capture a lot of different information. On the other hand, a lot of interaction with the field could be done directly on the device. And, oh, some nice graphic. How it looks like. We can onboard directly the piece of the software. You should be aware that this very thin, light software, I don't know, takes 12, 15 megabytes. It means that it could be onboarded directly to the chipset. And as well, this quiet, intelligent software is able to get all of information from the sensor to provide some intelligence. It means that this algorithm will analyze online what is happening, what kind of bad symptoms happened around this environment, make the analysis and send to the cloud right information like alarm, or on the other hand, redirect the information and change the process how the sensor or controller has already configured. There are some functions, purpose-built for embedded CPU, MCU. Everything is standard. From my perspective, I as well tell you that because there is very simple software, it's not so simple, however, it's simple. Even from medium or junior developer, it is not so sophisticated to operate with the software. That is very important. This tool is not for very advanced data scientists. That is for young, junior, middle junior developer can easily adopt idea to the software and finally get right response. And some functions, I will not describe it to you, gonna have it on the slides. I think that because I will put the presentation on the one common disk, you can take it. However, those functions are available. What we got out of that? Huge efficiency around the whole system. Those small devices are really smart because normally how the IoT system works, you should remember that each sensor has probably one or two functions. The first one, capture data and send it to the cloud. In the cloud, we have some framework to make some analysis. In this case, whole of very consuming interaction with the sensor is onboarded, is embedded on the chipset. What does it mean? We are sending only information which is interesting for us and some other functions. What is important? The service works. We did several trials, as well commercial implementation in Europe. One, the most favorite, sorry, because I would like to go to the last slide, but there is as well areas which are perfectly using this technology. Conditioning monitoring. Through it, we will not send information about certain parameters of the environment to the cloud. We can make analysis directly on the sensor. On the other hand, predictive maintenance. Predictive maintenance and in fact, the process which is going to change the process how the sensor or this controller, works could be done directly on the sensor. Predictive alarming. This one case is very nice. I still have a time because I can give you quite a nice example. As you probably know, the biggest problem with electric cars, there is engine and battery, of course. This engine is quite, tight. It means that in it, there are not a lot of space. It means that you cannot put some sensor inside. For instance, to check the temperature. It is extremely hard in order to just measure what is the temperature inside the engine. There are some processes and some scenarios that if the temperature is high, It could even destroy the engine, and finally you have a problem with our electric car. What we can do in this scenario? We will just putting in the laboratory environment this algorithm. We are onboarding this algorithm, thin algorithm, to the engine, to the chipset connected with this, in fact, to the engine, because this engine is quite intelligent. We are just putting the software, the piece of the software to the engine. This algorithm, small thin algorithm, is learning the normal behavior of this engine. Afterwards, this algorithm is going to the laboratory. We are learning the algorithm, we are teaching the algorithm, or the algorithm is learning how will behave in the certain status of the temperature, and after that we are moving back this algorithm to the engine. What is important? Thanks to that we know where there is the critical temperature on the engine without any sensor. That is extremely important. And this case is exactly about that, the trial we did, almost final commercialization project together with Volvo, for instance. Predictive control and device modeling as well. Sensor is efficient if you know what we would like to get from the sensor. And we are aware what kind of parameters we would like to measure. That from time to time, if we know how to, in fact, teach the algorithm finally certain parameters of the device, finally we will just get better information about the environment. There is one of my favorite cases connected with bridges in Malmö and in Copenhagen. There is a project, finally when I got this case, I just tried to translate what does it mean, dehumidifiers. Do you know what is it? Because I didn't know. However, I got this information. However, this element is crucial to appropriately assess the condition of the bridge. It's extremely important that those elements are connected with the bridges. If you are just equipped these dehumidifiers with some intelligent sensor, it means, and those two things are connected together and they have some intelligent insights, they will just learn the normal conditions of the bridge. And finally, all of interaction with this bridge, some maintenance, supervision, etc., according to weather conditions and other conditions which are happening around the bridge, there is water as well, the humid, etc., we are much more efficient, and my colleagues as well got some certain very useful information how to even predict what's going to be, how to prepare the maintenance team to go and fix something on mainly and maybe as well to do some maintenance before certain period which is signed or which is put in the agreement with the vendor. Extremely nice case connected as well with the city, Copenhagen and Malmö. I think that you will as well get this information from the internet. I think that Copenhagen just shared this information because it's quite advanced and quite intelligent way how we can protect our bridges in the city. Use case condition-based monitoring at maintenance. And of course, what you can get, current status, predictive, prescriptive, and cognitive, because everything is done on this very small thin piece of the software created using C++ programming methods. Addition to that, I have still 2 minutes, yes? I calculated very well my presentation. What is important, if you really would like to create some intelligent solutions, like intelligent systems, it's not only to buy the system and implement it, launch it. We should know much more about some details which are connected with the systems. There are, of course, certain areas just to create very efficient and successful service. However, finally, this one, what I just delivered to you, probably will give you the guarantee that service is not stupid, it's not dumb, but of course, you as well have some teams, some people, which can adopt this solution for certain, in this case, smart city service. Thank you very much. I hope that I wasn't boring a lot. That please, big applause for me. I will be so appreciated for that. Thank you very much.